Okay, so today we're getting into chapter 8, and this chapter is called What's My Curve? So the last chapter was called What's My Line? Today we're going to be working with some data sets that maybe linear model isn't appropriate, and there's more curved pattern to the data that we see, okay? The first thing we're going to do is we're going to take a look at this example problem. We're going to work through it together, okay? So it's talking about child mortality rate and income. So it says child mortality and income. What does a country's mortality rate for children under 5 years of age tell us about income per person for residents of that country? Okay, so we're looking at what this mortality rate tells us about the income. Okay, so we're going to use the mortality rate as our x, as our explanatory variable. We want to know what is that telling us about the income, or how is the income responding to that? Okay, now it says here, bless you, put the data into Desmos, draw your scatter plot and residual plot. We're going to draw two different plots right here in this space, just rough sketches of those. Okay, so the first thing we're going to do is we're going to take this data, we're going to go to Desmos, and we're going to insert our data into our table. So I want you guys to go ahead, insert your table of values, and let's start putting those in. Okay, be careful on this one that you take your time. You don't want to accidentally make a typo on anything. Okay, so we're just going to go ahead, give you guys a minute to insert that. All right, so how you guys doing with your data? You guys still working on inserting it all? Okay. Okay, now what I'd like for you guys to do next is do your line of best fit using the linear model. So we're going to do y1 tilde mx1 plus b. Okay. Now, when we look at the line of best fit, I'm going to put a line in there. You've got two dots up here that are really high, and then you got most of your data down here. Does this line look like a very good representation of the data? No. Like when we're looking at this right away, we see, that doesn't really look great. Hold on. Okay, so let's plot our residuals and see what happens with our residuals. So everyone go ahead and click plot on your residuals. And you see, here's your residuals, right? There's a couple up here, then they kind of drop down below the x-axis, and then they start to trend upwards and rise above the x-axis, okay? So what I'm seeing with these residuals is they're almost going in like a U shape. Can you guys kind of see the U shape that they're following? It's kind of like a tilted U. Does that make sense? Okay. And so I don't necessarily believe that these residuals are random enough to tell us that a linear model is good for this data. Okay. So what your notes want us to do is it wants us to draw the scatter plot and the residual plot. So we're going to draw these as two kind of separate plots so that we could look at each of them individually. So let's draw an x and y axis. This one will be our scatter plot. Okay, and for our scatter plot, on Desmos, so you can see your scatter plot better, you can actually turn off the residuals by clicking on the dot next to the E1 in your table. It will, like, they're still there, they're just not turned on right now. So you can click this dot up here to turn them off. You can also click your dot on your line of best fit if you want to turn that off as well. Okay, so if we're just looking at our scatter plot here, we're just going to do a rough sketch. Let's label our axes first. This is mortality rate is our x-axis. And our y-axis was income per person. Okay, maybe I'll just make like a few little markers, like my highest dot is right below 40,000. So maybe I'll just note that number. And then my farthest dot over here is just maybe past 150. So maybe I'll note that number over there. But I don't need to get super detailed. It's just a sketch, okay? So let's go ahead and sketch. All right, I've got two dots that are kind of high up over here, right near the y-axis. Then when I'm looking, I've got a cluster of four dots kind of over here and two below it. So maybe I'll graph those as best I can. Something like that. I've got two kind of down below, down there. Then I've got another clustering of four dots over here. So maybe I'll try to graph those as best I can. Got another dot's kind of starting to get spread out. And then I've got another one right past 150. So maybe kind of something like that is a good sketch of my scatter plot. Okay. Now, if you want to, you can kind of draw in your line of best fit. So your line of best fit did something kind of like this, right? This was your line of best fit. Now, when I'm looking at this, we talked about linear. We're not really sure if linear is the right move there for our line of best fit. Does that make sense? Okay, so we're kind of questioning that. Doesn't really fit the data very well. Okay, now let's draw our residuals. So I'm going to turn off these two on Desmos. And I'm just going to turn on the residuals so we can draw a scatter, like a rough sketch of these residuals. So everyone go ahead, draw another X and Y axis. Okay, in this one, I'm going to put mortality rate way down here because I do have some dots below the X axis. So I'm going to leave some room for those. This is still income per person. Okay. My highest dot is kind of just above 20,000. So maybe I'll note that point here. And then my farthest dot is just beyond 150. So maybe I'll note that over here. Okay. So let's go ahead and start sketching. I have a dot real close to the y-axis above 20,000. I have another one below. Then I have a cluster of dots that kind of drop down below here. So there's like 4 of them. And then there's like another 2 down here, right? Maybe I should have extended my axis down lower, my y-axis, since I have points on below down here. And these are almost at negative 10,000, right? Okay. And then I've got 2 more dots kind of over here. And I've got another 2. They're kind of coming up, approaching the axis. And I've got another one over here and another one kind of up here. Does that kind of look like a rough sketch? Okay. Now, what I'm kind of noticing in my pattern with these residuals is, like I was talking about, that they kind of make almost like a U shape, or kind of like a curve that goes like drops below the x-axis and then it comes back up and around. So when I'm seeing a curve here, this is definitely not random, right? I'm not getting that random, sporadic, like all over the place pattern in my residuals. Okay. And so what this is telling me is my hunch that I had about this being linear being the best fit is probably correct. Okay. Linear is not really an appropriate model for this data. Okay. All right, so if you're ready, flip over your page here, and we're going to take a look at a couple things. Okay, so number 1, the scatter plot shows a negative association. It was, when we looked at it, going downhill, but it's clearly not linear. Okay, the residual plot confirms that a linear model is not appropriate. Okay, when we looked at the residuals, when we get a bend or a curve in the residual plot, it confirms that the linear model is not appropriate. Okay, so when we have that, it's time to look for a better model. So linear models work well with things that grow at a constant rate. Okay, that means kind of like things that grow in a straight line, right? Okay, exponential models involve growth that accelerates. Okay, so maybe when we see something that might look kind of like that. Okay. Now, when we have this thing happening where we've got the linear model doesn't work, okay, we want to check an exponential model. Okay, we also want to check a power model, which is similar to an exponential model. Okay, but we might also want to check either one of those models. Okay, now I'm going to write down the equations for those models. Okay, so I didn't leave a good space for this. We'll just write it down here. Other models to check. Okay, one is going to be your exponential model. to check that model in Desmos, you're going to type in y1 tilde a b to the x1 power. So the x is up in the exponent. Okay. Now the other model you can check is the power model. Okay, and to check that one, you're going to type in y1 tilde a x1 raised to the b power. So the b is in the exponent on that one. Okay. And what we're going to look at right now is we're going to look at, when we check those two models, which one seems like a nice fit for this particular data. Okay. So did everyone have enough time to write down those two? Okay. So now what I want you guys to do is you're going to go back to your Desmos, and below where you typed in your line of best fit, okay, I want you to make sure you have your Y values on. You can turn off your residuals so that you're not seeing those. So on your Desmos, make sure the Y values are on, the residuals are turned off, turn off your line of best fit. Okay, down here on the third row, below where you typed in your line of best fit, we're going to type in the exponential model. Y1 tilde A B. You guys know how to do the exponent in Desmos? You can click on the keyboard, and this A to the B button will give you the exponent up in the exponent place, so x1. Okay. Now, once you type that in, how does that blue line on my graph look? Does it look better than the straight line? Does it look closer to most of the data? Okay. So this model, which is the exponential model, is definitely looking a lot better. Okay. Let's also type in the power model. Okay. So on the next line in your Desmos, we're going to type in the power model, y1 tilde, and then do ax1, and then get your exponent going. And then we're going to put b up in the exponent. Now that's the green line this just graphed. Which one looks better to you guys? The blue line or the green line as far as fitting my data values? What do you guys think? Blue or green? Yeah, green. So this power model, this model probably is actually the best fit for my data, right? If I take a look at this power model, this is going to be a better fit for my data than like an exponential or even a linear, okay? I mean, both the exponential and the power are way better than the linear, right? But probably out of the three, the power model is the closest one, okay? And so if we wanted to write the equation of our line in the power model, we have down here under your parameters, you'll see they're no longer giving you M and B. What are they giving you instead? A and B, right? And so we would plug in A and B here, okay? We'll work on that more on a later date on how to write the equation of the line when you have a power model or exponential model, okay? That's going to be it for our notes for today.